Yes.
Ankur sir. Yeah.
Yes, sir. Good afternoon, sir.
Good afternoon.
Good afternoon.
Yeah.
Good afternoon, Mr. Rashmikant Thakkar, sir. And we gracefully welcome you to this session.
Thank you.
And it's our good fortune that it's being possible to have people from the field and sharing their valuable time, otherwise, which is very difficult. So we appreciate your support, and I think along with me, all the participants are eagerly waiting for the moment where you will start your session. I think, sir, we should start.
Yeah,
Yes.
sure. We can.
Yeah, please, sir.
Let us have sir introduction and then sir can take over. Ankur sir.
All right, so I'm fortunate enough to introduce today's speaker and expert, Mr. Rashmikant Thakkar, to the audience. Like, he's the team leader, Turner Sikka Consortium. So Thakkar sir is working as a project manager at Turner Project Management India Private Limited for last 10 years. Mr. Thakkar is a 1992 engineering graduate, and he has more than 30 years of massive experience in the construction industry. So from this, we one and all, we can very well imagine the source of knowledge that you are going to get today from this session. So he's in construction industry since last more than 30 years, and in the field of construction management also. So sir has also worked in the residential, commercial, industrial, monumental and tourism projects. So that where sir's expertise reflects itself, that why and how he must have started his the exciting work on this Statue of Unity. From the year 2012 to 21, he was part of the construction of the Statue of the Unity project, Gujarat. And he also is involved in concept design, tender document preparation, tendering procedure, and award of EPC contract, construction of SOU, testing and commissioning. So friends, we can say that we have one-man army with us. So regarding the this particular project of Statue of Unity, which is considered one of the most prestigious projects of India till date. So with this small and brief introduction, I will welcome Thakkar sir to start his session. And sir, over to you, sir.
Thank you, Dr. Ankur. I would request the permission so that I can share my screen.
Yes, sir. Amit sir, please do the needful.
Yes, sir.
Yeah, I got the permission. Welcome everybody, and good afternoon everybody who is online listening this session. I'm Rashmikant Thakkar. I'm working with Turner since last 10 years, and this was one and only project I completed with Turner. I'm not discussing much about this project because this is our session, and we'll see the entire presentation. We will discuss a lot of things during the presentation. So let us start our session. You are waiting since a long, I know. I would definitely like to introduce my company, Turner. Turner is basically a US-based company. We are working as a general contractor in US and Canada. And outside US and Canada, we are having a presence in almost 60 countries, including India. In India, we have almost 450 strength, and we have a presence of almost 12 cities. Our purpose is to make a difference in the life of people, customer, and community. And our vision is be the highest provider at global construction service and technical expertise. One most important thing at Turner is building life. Life is very much important, and we have a slogan of building life. What is we defined it as living injury free every day. So our motto is to do the construction with maximum number of safe man hours and bare minimum, because zero tolerance in our company for the accident. So we definitely try every time to give the living injury free every day. Turner has done, as you know, Statue of Unity. In addition to Statue of Unity, we have also done Indira Gandhi International Airport, which is about to complete at present, War Memorial, which is completed at Delhi, Mall of India at Delhi, which is a retail space, which is already completed, Bangalore International Airport, which is under construction and about to finish. And this is just a glimpse. We have done a lot more projects in India, and many other projects are going on also. At present, we are doing another statue, which is Adi Shankaracharya at Omkareshwar, and I'm working on that project. Basically, you will definitely want to know that what is project management and what it includes. So project management is basically nothing but complete management of the project right from day one. That will include pre-design phase, design phase, finalization of EPC contractor, construction phase, and handing over phase. Pre-design phase is where you collect all the information and start the concept design. After collecting all the information, you will do the design, which will be a concept. Then after, generally big projects are being done in the EPC mode. EPC is the engineering, procurement, and construction. The contractor will do all the works. They will develop the design based on the concept design. They will procure all the material and they will do the construction also. That is why it is called EPC mode. So basically consultants are doing the concept design. So concept design is the second phase. Third phase is the finalization of EPC contractor. Along with the concept design, tender document preparation is one more important thing. And after completing the tender documentation, you know that we have to do the tendering process to finalize the EPC contract. And after finalizing EPC contract, EPC contractor will do the complete construction. And the end phase of complete construction is the testing and commissioning. After testing and commissioning and completion of construction, we have a handing over phase. People generally understand that handing over is just a write-up to the client. We just do the write-up and hand it over to the client, but it's not like that. It's a very tedious and very long phase if you are not properly documenting each and everything. Still, many of the projects completed 2, 3, 4, 5 years back, but handing over is still a problem. So handing over is very important phase. Everybody has to take care of that phase. However, it's a very small phase. But if everything is documented properly, you have all the documents readily available, you can do the handing over very easily. Now, this was the general introduction. Let us start the discussion on Statue of Unity. This was the stakeholders and the general arrangement for the project. So, government has constituted a trust named Sardar Vallabhbhai Rashtriya Ekta Trust, who was client or owner of the project. And since Sardar Sarovar Narmada Nigam Limited was having a setup at Kevadia, Sardar Vallabhbhai Rashtriya Ekta Trust has employed them as an employer. After Sardar Sarovar or Narmada Nigam Limited's employment, we worked as an engineer's representative. Turner has worked along with Michael Graves and Associate USA and Meinhardt India Private Limited. So Turner has worked in a consortium. Meinhardt was a special in services, while Michael Graves was having a specialty in architectural design. So in a consortium, Turner has started this project, and After completing the tendering process, we have appointed Larsen and Turbo as a contractor. Now, this is very important pictures. You see two hillocks. One is on the top left, which I have taken the photograph in 2012 November. I joined the project in 2012 October, and in 2012 November, I have visited the place. This is the hillock. I have taken the photograph in 2012 November, and the photograph below is 2013, where we had a high flood. You can see the hardly top area is visible in that. And the top left picture, which I have taken in 2012, is having 70.5 meter hilltop. To build this project, we have lowered down this hillock to 52 meter level. So almost 18 meter we have reduced the level of this hillock to construct this. And that was the starting point of this project. This is a general information about the project. Statue of Unity we have awarded at 2989 crore, which is almost $460 million at that time. In this 2989 crore, 2,332 crore is a construction cost, and 657 crore is the operation and maintenance for 15 years, which was started in the month of November 2018. This work has commenced on 3rd of December 2014, and as everybody knows, this work was completed on 31st of October 2018 and inaugurated by our Honorable Prime Minister, Mr. Narendra Modi. So we took almost 47 months to complete this project. Now this is a Google map, and this is a layout. Just 3 kilometers downstream of Sardar Sarovar Dam, we have a statue and a museum plus a memorial and visitor center. And further 5 kilometers down, we have a Shrestha Bharat Bhavan, which is a hotel and parking area. Both the hotel is on the bank of river, while the statue is on a hillock or island within the riverbed. This is once again the same arrangement. If you see, we have statue base, main bridge, and memorial and visitor center at one place, and Shrestha Bharat Bhavan or hotel at another place, and a road connecting these two places was a part of our scope for a phase 1 construction. If we talk about the statue is 182 meter, which is equivalent to 597 feet tall. And if we consider the level wise, the deck level of the bridge was 58 meter. The top of museum or statue base is 83 meters. So our podium or museum is 25 meter high, and the figure of Sardar Patel is 157 meter. If you total all together, that is 182 meter. And you will definitely love to know the history behind this 182 meters. Why our current Prime Minister and Chief Minister at that time, Mr. Narendra Modi, has decided this figure, because Gujarat is having 182 constituencies, and behind this number, the number of constituencies was there somewhere there in our Honorable Prime Minister's mind. So to make this Statue of Unity happen, we have casted the bronze of 21,099 square meter, which was having 8 millimeter of thickness. So if you calculate the weight, which is around 1900 metric ton of bronze we have used in this statue. Within this statue, we have two high-speed elevators at a 4 meter per second. This looks very small, but you convert it into the higher unit, you will know what is the speed per hour. And this is a lesson for you to do that calculation. This statue we have, however, code provides 39 meters per second of wind speed, but we have designed a little bit higher side, and this statue can withstand 50 meters per second of a wind load. And everybody knows that Narmada Dam area is a fault zone. So we have considered one zone higher for this statue, and we have designed this statue for 6.5 Richter scale at a depth of 10 kilometer and within a radius of 12 kilometers. So it will be very much safe even we have a earthquake in that particular area. Now, every project is having the challenges. We'll definitely discuss the challenges. These challenges are in basically two different zone. One is earlier challenges, which is a design period challenges, and second is a construction challenges. So each and every civil engineer knows that a base should be sufficient enough to take the load. If you see the figure, Sardar Patel's figure in this photograph, Sardar Patel very dhoti, two separated legs. So we were not having a strong single base. The base was divided into two parts. So designing for this particular posture was a challenge for us. Second, seismic area. We discussed that this area is in a fault zone. So seismic zone, we had to consider to give a proper safety to this tall and massive structure. So we did that also. Further, if you see, Narmada right from Amarkantak to Bharuch is flowing in between two ranges of mountain. One is Satpura and other is Vindhyachal. And between these two ranges of mountain, we definitely feel a wind tunnel effect. So because of the wind tunnel effect, your structure design must be capable enough to take a particular wind speed. I already told that we have considered the 50 meter per second wind load, but that is after we completed the wind tunnel test. RWDI is a consultant appointed for this particular purpose, who is based at Canada, who has done the complete modeling and tested the wind tunnel effect and suggested to go for a 50 meter per second of a wind speed. So the statue we designed at a 50 meter per second wind speed. Second, we have seen in this photograph that in between the river, we don't have the space to store the material. So that was the another challenge, because this hillock is almost 300 meters inside the river bank. So to transport the material 300 meters inside is a challenge. And second challenge was to store the material, because at that place we were not having any plain area available to store the material. So that was another challenge. Second thing, to get the required area for the museum was also a challenge for us, because after lowering down the island from 70.5 meters to 52 meters, we have got almost 62% of our area requirement. So we have done a huge mass concreting around the hillock, and we have created an additional area to place the museum. The museum is around 7,500 square meter. So we have created almost more than 2,400 to 2,500 square meter area additionally by doing the CLSM, lean concrete, which is 0.75 MPa strength. And we have created an additional area to place the museum. So that was our another challenge. And as we know, this was the first time ever project. So it was never designed, never constructed. So that was another challenge for us to complete the design as per the required code, required standards. safety, all this thing, keeping safety, fire hazard, everything in a mind. And we have taken a help of not many consultant and experts to complete the design, review, vetting, everything, and we did the design with the help of them. Now, the final thing, which cannot be considered as a final, because this is one of the bigger challenges. We definitely had small challenges, which is very long list, and we cannot discuss each and every of them. But finalization of architectural features was also one of the challenge, because Sardar Patel's photograph we are having are very less, and to decide which photograph we have to consider to make this statue, or what could be the age of Sardar Patel, what could be the stance of Sardar Patel statue. So that we had a very long discussions and deliberations. Finally, we decided to go with a statue at Sardar Patel International Airport, Ahmedabad. A black statue is there at airport of Ahmedabad. So we decided to go with that, with a walking stance of Sardar Patel, to show a little dynamism, because Sardar Patel was a dynamic personality, and to give the proper justice to his personality, we decided to go with that particular stance. Now, to complete this, government has given us few governing decisions. We just discussed regarding the walking stance. We have also discussed regarding 8 mm thick bronze as a cladding material. Based on the wind force and structural calculation, our experts has decided that the bronze plate below 8 mm thickness will not be sufficient enough. So we need a minimum 8 mm thick bronze panel to withstand the wind pressure as well as structural forces. So we have decided minimum 8 mm thick bronze as a cladding material. Then third one is an international standard of foundation, structure, fire egress, vertical transportation, etc. to be met. I just said that this project was being done very first time. So it was found that for some of the items, we are not having the code or standards available in India. In that case, we decided to go with an international standard, and fire egress, vertical transportation, structure design is very much important aspect of any of the structures. So we decided to go with the international standards of this particular structure. Now, it was a dream of our Prime Minister, Honorable Prime Minister, Mr. Modi, that we have to encourage the use of locally available material. And he has instructed us to keep this thing in our mind. So we also decided to encourage the locally available material. And this was his own dream, to have a boat ride or a cruise. And he instructed us that entry through the water and egress through the main bridge has to be kept in mind while doing the design of this particular project. And everybody of us are knowing that to 20,000 square meter area is a limit from environment clearance. If it will go beyond that, we have to go to the center for taking the clearance. So to avoid that clearance, we have decided not to go beyond 20,000 square meter for this particular project. Now, we have designed the tender document in such a way that we have asked for the contract, asked for the help of all this consultant to be appointed by the EPC contractor, so that we will have a expertise available, because this project was being done at the very first time. We had hydrological consultant, we have infrastructure consultant, we had landscape consultant, we have interior designer, lighting consultant, acoustic consultant, traffic and parking, a design consultant, life safety consultant, specialist for area calculation consultant, pedestrian movement consultant, a BMU consultant, audiovisual consultant, security consultant, kitchen consultant, exhibit consultant, and wind tunnel consultant. This 16 number we have provided in the tender, and after coming on the board, L&T have appointed all these consultants as a minimum. Over and above this, also there were few consultants appointed by the contractor, and that we will show at a later stage when the stage will come. First step was to finalize the statue aesthetics. So government decided that walking stance of Sardar Patel at an airport, that to be considered, and age to be considered is around 62. So we have done the 3D scan of that particular statue to finalize the architectural features of Sardar Patel. After L&T came on board, they have done the scanning of this complete statue at International Airport, Ahmedabad, and they have prepared a 12-foot high fiberglass statue, and they have put up for the public consultation at Bardoli. So we have invited all the people, and maybe few people who were accompanied Sardar Patel during his life. So they visited Sardar Patel's place, Bardoli. They have seen that statue, they have given the input, and after incorporating the inputs, we have finalized one figure that was again scanned, and with the help of different softwares, we have prepared a 3D model of this particular project. And after that model, also we have done the mock-up of some of the body parts. You are seeing the face of Sardar Patel in the museum when you are going to visit the Sardar Patel statue. So that facial part is also one of the mock-up we have prepared for this particular project. This is the same which we have seen in the museum, which we have kept, and these are the process. From 3 foot, we have enlarged it to 18 feet. From 18 foot, it is again enlarged to 30 feet. And then from 30 feet to 1:5 scale, mock-up prepared in FRP, and then it was converted into the bronze mock-up, which was brought to the site in October 2017. And after taking the consent from all the concerned officials of government, we have finalized this as a phase. And again, this phase was scanned, and we have done a full-scale mock-up at China, which was approved by none other than the main sculptor Ram Sukar himself. And then it went to the production, and we have received the parts of the face, which was erected and completed the statue in October 2018. Now, after completing the design, it was the work of construction, which we started on 15th of December. Our Honorable Chief Minister of that time, Anandiben Patel, has started the construction of the main foundation of the statue. You can see this statue foundation is almost 4,600 cubic meter, which is having a dimension of 44 meter by 34 meter by 3 meter depth. At the time of starting the concrete, and even during the concreting also, we continued shouting the labor, because 3 meter depth is more than a room's depth. So we continue shouted from the top that if somebody is inside, please come out, because that huge this foundation is. We took almost 132 hours to complete this massive foundation in M60 SCC. SCC is a self-compacting concrete, which you don't need to do much compaction. It is a free-flowing and self-compacting concrete, which will help you to reduce the voids within the concrete. Now, if you see, after completing the foundation, we have done 2 core walls. In each of the core wall, we had a lift inside this particular course, which is taking you up to completely up to the chest level. This core wall, for the structural stability purpose, are connected with the coupling walls, and from the core wall we have primary and secondary steel coming out of it, and primary and secondary steel are joined with the tertiary steel, which was welded behind the bronze plate, and bronze plates were erected and bolted with this particularly primary and secondary steel, and we have completed this complete statue. We started in the month of October 2017 and completed in the month of October 2018. As we have seen, we have completed the raft of around 4,600 cubic meter. Now, if you see core wall details, that is also a very huge structure. Core wall is a 153 meter high, 11.3 meter by 8.4 meter elliptical section, and the thickness is 1.3 meter. And you will be surprised to see that we have casted in a 4 meter high lift. Every 4 meter piece of this core wall, we had 92 metric ton of reinforcement steel, as well as 165 cubic meter of concrete, and we started with a cycle of almost 45 days per lift, which was reduced down to 7 days per lift at the end. So this was our one of the biggest challenge to complete this core wall. Total reinforcement of this core wall is 4,620 metric ton, and to join the primary and secondary steel, we had insert plate within the core wall, which is 280 metric ton, and total concrete of this particular core wall is 13,500 cubic meter. Now, to give a structural support to this core walls, we have a coupling walls starting from 115 meter level to 193 meter level, which is a structural component of the project. For this particular statue, 2,600 metric ton of a structural steel as a primary and secondary, and 1,800 metric ton tertiary steel we have used, and 21,100 square meter of bronze cladding we have done, which is around 1,900 metric ton, and from that bronze we have casted almost 6,000 micro panels, which we have made 550 macro panels. We'll see as we go on how we have converted the micro panels into macro panels, and what was the mechanism we have done, that we will see as we go on. Now, this is the mechanism, the cycle time, the construction detail for the core walls and coupling walls. If you see the freestanding core walls are 60 meter, and within that we had 14 lifts of 4.4 meter each, and casted in 246 days from completion of first lift. Then if you see the central part, which is with the coupling wall, which is 81 meter, which consists of 18 lift, we have casted in 182 days. Cycle time, minimum cycle time was 6 days. And above the coupling wall, we had again freestanding 13 meters, which we casted in a 4 lifts and 24 days. And we have used the special formwork also to cast this, that we will see later. See, this is the final lift of core wall. When we cast it, we have used the Perry jump form, which is an automatic climbing system for this particular core walls. It is a formwork which keep on jumping as you complete the core wall. And within the core wall, we had 2 tower cranes and 1 tower crane outside, plus one Lafarge crane on the edge of the core wall. So we have used total 4 tower cranes to lift the panels, to do the concreting and shuttering materials and reinforcement, everything. So this core wall not only taking the complete load of statue, but during the construction, it has taken the load of this tower crane also. And tower crane was also a self-jumping tower crane. With each and every lift, we keep this tower crane also jumping up so that it will be utilized as and when required. Now, this is a plan of statue. We have vertical and horizontal transport system. As you go towards the statue, we have total 8 travelators which are on the main bridge, which is a exterior type travelators. And once you enter the statue area, we'll have escalators through which we can go up to the feet. And we have 10 numbers of escalators, 5 on each side, from 58 meter level to 83 meter level. And it has a capacity of 9,000 persons per hour. So this vertical and horizontal transportation system is also there, but this will be utilized only after the construction. During the construction also, we have utilized vertical and horizontal transportation, because without vertical transportation, we cannot move the labor and material up. So we have also used passenger hoist to take the labors, to take the materials up and to complete the work within required time. Now, as we have discussed, we have designed this statue for 50 meters per second of a wind load. And if we make the statue stiff, then it will be a structural issue against 50 meters per second of a wind load. So we have to allow a free sway of the statue. Otherwise, there'll be an issue with the structure. There'll be a cracking within the structure. So we have allowed 1 meter sway of the core wall, a free sway. And to control this sway movement, we have installed tune mass damper, which will control the sway to 1 meter and will not allow more than 1 meter sway. If you see the core walls here, from 196 meter to 209 meter, we have a freestanding core walls wherein we have placed this particular tune mass damper. We have used 2 dampers per TMD, and 200-ton mass hanging from the frame has been used to control this sway well below 1 meter. And we have a structural housing, structural steel housing to hang this particular tune mass damper. The photograph is a bottom slab of 196 meter level, and the frames we have placed for the hanging tune mass damper. Now, while construction, it was very much important for us to do the site management and site logistic. Without having a proper logistic, we cannot complete the construction work. As we all know that this was constructed well in riverbed. So we have constructed a temporary bridge across the river from mainland to the island to transport the material, machineries, and for the labor transportation, plus for construction of a main bridge, which we are using right now. We have created a storage area below that bridge so that we can do some construction work during the dry season. and we have used that particular area for storage and construction material. We have casted even the girders of the bridge within the riverbed, and that area was well utilized. Now we have divided the statue base into total 5 zones, and the zone 5 and zone 3A, which are just next to this temporary Bailey Bridge, which we have converted into the temporary yards to store the panels which are coming from the assembly yard. Again, we had 4 pre-assembly yards which was having a flat concrete beds. We have done the pre-assembly after bringing the bronze plate micro panels, particularly from China. We have done the pre-assembly. Again, we have dismantled it in a macro panel, and we brought it to the site. We have stored it in zone 5 and zone 3A, just next to the temporary bridge. And then from there, we have lifted it and erected it as and when required. After that, we also had a project office, mock-up room, store and storage area. And we have 2 RMC plants with a capacity of 56 cubic meter per hour of a concrete production. This is the key plan of entire area. You can see statue is connected with main bridge. On the bank of river, we have a Memorial and Visitor Center. Just next to Memorial and Visitor Center, we had a site office, and the temporary Bailey Bridge is also there. The bridge where connecting to the statue area is a zone 5, which we have used for temporary storage of the structural steel. And further left of that Bailey Bridge, we had a permanent site office plus batching plant plus assembly yards. All the infrastructure we have created in this remote area, and we completed this construction within the stipulated time period. Now, if you see the detail of Bailey Bridge is 225-meter long temporary bridge which we have constructed across the river Narmada up to Sadhu Island. This bridge is having 9 span of 25-meter each. And this is for the transportation purpose of man and machineries. While doing the statue main foundation, we have laid a concrete pipe across along the bridge, and we have pumped the concrete right from the outer end of the bridge, and we have poured the concrete within the foundation. So this was utilization of this bridge was started from day 1 itself. And because it's a steel bridge, for the safety purpose, if the vehicle is below 30 ton, we have allowed the speed limit of 10 kilometers per hour. And if it is between 30 to 100 metric ton, we have restricted the speed limit up to 5 kilometers per hour. And this is not the just on the paper. We have put up a very special people also for to check all these speed limits and control the speed limits. So at site also, we did all these things which was required for a safety purpose of this Bailey Bridge. We discussed regarding the vertical transportation. Now this is the vertical transportation arrangement. One luffing crane outside the statue, one luffing crane within the statue, one crane outside the statue area, and one placer boom was utilized to construct this particular statue. And since this is a vertical expansion only and no horizontal expansion, vertical transportation and managing vertical transportation was most important. We also had 2 passenger hoists, one each in 2 posts to shift the material, to take the labels also up and down. And For concreting purpose, we had a placer boom, which was also placed within the core to transport the concrete and pour the concrete in these two core walls. These are the positions of different cranes and capacity of cranes. LC1, we had a capacity of 20 metric ton, which was inside core A. LC2 was having 16-meter capacity, which was outside the core. LC3, which we have inserted at the later stage, it was having a capacity of 8 metric ton, and you see it was a cantilever. Now, this was the biggest challenge for us, because crane itself need a solid foundation, and we have adjusted and put up as a cantilever. So crane itself was a cantilever. Taking 8 metric ton of a load was certainly a new thing for civil engineering. And we also had a derrick, which was 8 metric ton capacity, and it was above the core. Now, to do this project, we need certain mechanism. For that mechanism, we have divided the entire statue in 25 horizontal levels, starting from A to Y. You can see in this photograph all the levels we have marked, and all the cross section of a horizontal section of a statue is further divided into the micro panel. And we have divided the entire statue in lower leg, lower body, upper body, and head and shoulder. And for particular this statue, as we discussed, we have used 550 macro panels, 1,800 metric ton of panels of bronze, 1,850 metric ton of steel, and we have completed this within 10 months. This is a bronze and tertiary steel details, and we have used 2,600 metric ton of structural steel, 62 frames, 2,300 infills, and this was also completed within 10 months from the starting. Now, fabrication of this micro panel and macro panel is a very interesting subject. After getting the panels from China, the complete process, what we did, that is very interesting to know. What we did is, we did a marking and cutting, we did a assembly, we did welding, then visual inspection, then non-destructive test, then we did a shot blast, we did a galvanization, we did painting, and then dispatch at site. So almost 9 activities we have performed before sending the panel at the site for final erection. And as we discussed, at the site also, we have made couple of yards above the slab of museum to store this particular panel for lifting. On the core wall also, we have done the stub welding with the insert plate of core wall, and from that stub we have bolted the primary steel, 62 frames of the primary steel, which was having the secondary steel infills. And parallel with the structural steel fabrication, we have done the pre-assembly work of each and every level at the yard. We had 4 yards at the site for doing the pre-assembly of complete level of that particular area, and then we have again dismantled it from micro panel. We made it into the macro panel, and we have transported it onto the site. Now, the first important point which we did is a grid marking on the ground. So based on the profile of the level, we have done the complete grid marking on the ground. And after doing the grid marking, we have placed the tools across that grid marking. After placing the tools, we have done, as you see in this photograph, we have placed the complete tertiary steel frames. And after placing tertiary steel frames, we have joined the bronze plate along with the tertiary steel, bolted it properly, and from behind and from front, we have welded it. Now the copper welding is known as brazing, and we have brought the special welders from China, who have done this welding work in a required speed to complete this project. After doing this, we have done the shot blasting, sand blasting over the bronze panel, and each and every macro panel. After completing this, we have dismantled this complete level in a macro panel. One micro panel was 2.2 to 2.75 meter area, whereas the micro panel was with the assembly of 3, 4, 5 to 6 micro panels as per the requirement. These are the special features of the body which we have done very carefully. One is eye, one is nose assembly, one is finger assembly, because it is very important to keep it actually as per the mock-up done. So we did the utmost care to project as many possible as features we can do, and utmost care has been taken in this particular plates. As you can see here, copper blasting is also done, and after doing in the copper blasting, we have done the surface cleaning, and the surface, which was initially a little bit reflective, was become a completely non-reflective surface after the stone blasting. And after completing the erection, each and every panel we have kept the RFID, radio frequency identification. You can see this yellow strip, which is a RFID, which will show the size of micro panel, where it is located on the statue, what was the date of manufacturing, date of shipment, when it was inspected, what is the laboratory test report done in China, what is the laboratory test report done in India. So each and every information is stored in that particular radio frequency identification strip. Now, when the discussion comes for this panel casting, we have done the panel casting in China because this big foundry is not available in India who can do the speedy work. So we have done it at a Jiangxi Metal Handicraft, China, and we have used the foam model FRP mold and sand. You can see from this figure, FRP mold, sand, and vents. Through vents, we have poured the melted metal in a sand so that the required shape and size of bronze panel can be manufactured. After manufacturing the particular panel, it was assembled there, it was tested there, and after completing the quality testing, it was shipped to India. In shipping India from Shanghai port to Mundra port, it took almost average 25 days, which is around 10,600 kilometer and 5,720 nautical miles. After reaching at Mundra port, it has taken average 10 days for clearance and dispatch, and after dispatch, again 3 days to come to the Statue of Unity site, which is around 560 kilometers. So transit time of 35 to 40 days from Shanghai to Statue of Unity, and each and every panel has traveled 11,000 kilometers to reach the destination. After completing this, transportation was also one of the biggest challenge because of the restriction of a road width and a restriction of a placement area at the site. So, and the capacity of weightage of each panel, which macro panel was around 6 to 7 metric ton, and storage and particularly transportation was also a challenge, and we have used of big trailers and big cranes with safety persons walking alongside these panels to safeguard the other people also, as well as to safeguard this particular panels also, who have contributed, the safety people who have contributed most on this project. And this is the fact and figures. In February 2018, we have just started with the structural steel erection. After 2 months, it was up to a considerable height. Legs were started in July 2018. We have almost completed the structural steel erection, and almost 40% of bronze work was completed. In September 18, we have completed the structural steel plus almost 70% of bronze were completed. In October 18, we have completed the statue. But after completion also, it was not completed. As you can see, tower crane was behind the statue. And to remove the tower crane was also one of the challenge, because removal is not only important. Tower crane was tied with the core wall within the statue. So once you remove the tower crane, then at the same time you have to plug that hole also. So if you lower the tower crane, you cannot reach to the hole, and without removing that particular support, you cannot fix the particular panel also. So that was also a challenge. So with the help of another tower crane at the site, we have done the complete erection, and we have removed that tower crane. And on 31st October 2018, it was ready for the inauguration by our Honorable Prime Minister. And what we did was this, the biggest and tallest statue of the world, which was highest in the world and double the height of Statue of Liberty and other statues. This is the comparison, you can see yourself. One more important feature of this statue is the patina effect. Since copper is a main component of this statue, copper with the oxidation will change the color. So from metallic bronze right now, it will turn to a greenish one like Statue of Liberty after 100 years. And the color transformation is known as patina effect. Core wall cycle time, we have discussed that we have started with 45 days cycle time of 4.4 meter height, which was reduced down to 7 days. That was the biggest challenge, and we started working in September 2016, and we have completed the core wall construction on 31st of December 2017. Now, these are the major consultants L&T has appointed to take a help in this particular project. Ram Sutar was the sculptor. DPA Lighting UK was the lighting consultant. HR Willingford UK was the hydrological and maritime consultant. Wood Begots from USA was the architect and interior designer. Arup, United Kingdom and Hong Kong was the structural consultant. EDRC of L&T was the structural consultant for structure other than statue. RWDI was the wind tunnel consultant. HCP Design Ahmedabad was a landscape consultant. Arup again was a cladding consultant. Tata Elxsi was a signage consultant, and Lord Cultural Resort was a exhibit consultant for this project appointed by contractor. Whereas as a Turner consortium, we have also appointed PricewaterhouseCoopers as a sub-consultant for their commercial and financial studies of the statue, which we submitted to the ground uh, to the client government of Gujarat, based on which government has done the recent all the development around statue. Last but not least, this is a teamwork, which is this is a teamwork, and without teamwork, we could not have achieved this project. This is my team, and I'm proud of my team who has done this thing possible. And this is also a team of a senior management who has keep us moving, who has advised us, who has continuously made us motivated to complete this project. These are some photographs of the statue we have taken during the construction. So we will definitely see before closing this presentation. Thank you all.
Yes, thank you very much, sir. It was indeed a nice presentation, and it has gone all the insight about the construction aspects of Statue of Unity. Obviously, it's one of the marvel of world, we can say, and this session, I hope that all the participants have found fruitful to understand all the construction aspects of Statue of Unity. So now first I will request Amit sir to take up the questions, whatever we have.
Dr. Tarak, Amit will quickly respond because there was some issue. So he's not there for a while. So in next 5 minutes, he'll be there. So meanwhile, we can also request participants, if they are interested, we can allow them to even chat with the expert. We can allow them to unmute themselves in case they can raise the hand, and we can do the needful. Right. So, Dr. Tarak, I think you can also suggest to the participants in this way.
Yeah, one question that we have got. Sir, are there any provisions for maintenance of bronze cladding and provision of access to the platform at height for cleaning of statue with safety aspect?
Yes, we have provided catwalk, we have provided monkey ladders within the structural steel framing so that a person can go inside, can tight the bolt, can do the servicing, and even can do the servicing from outside also. For that also we have made the provision of monkey ladders.
Then just, sir, one question from my end, that as you are involved in the design team,
okay,
you must have constructed many structures, and as you have mentioned that you are involved in many projects. As we can say, it's a symbolic structure in the world. What the most challenging task that you have faced for this structure compared to other structures? If you have airport structure or any other structure, compared to that, what is the most challenging task that you have observed, and then you have found out some solutions for that?
See, Dr. Tarak, I have already discussed, and again, I'll come back to all these points.
Yeah.
First and most important challenge we had was a separated base. Sardar Patel is standing on two legs, and dhoti is going up to the ankle height only. The base was in a two-part. The design of base was in a two-part, and also there was a gap between the legs, so wind can pass through that gap below the dhoti. So that was the biggest challenge. That was the biggest challenge for us, and for overcoming that particular challenge, what we did is, it is a safety requirement also. We have provided the coupling walls also, plus at every 11-meter height, we have connected two cores for more stability of the structure, so that two core itself will become a more stable, and we can give the more stability to the statue. That was the one thing. Second thing was a wind tunnel effect. Second important aspect of this was a wind tunnel effect. So we have done a miniature in a closed glass cabin. We have given a required wind pressure, and we have tested completely the complete miniature, and the RWDI, which was our wind tunnel consultant, has done it in Canada, and they have suggested that though the code provision of 39 meters per second is sufficient enough, but to safeguard the project, we have considered 50 meters per second of a wind load, and we forced contractor to go as per the tender provision of 50 meters per second, which was a little higher side. The third important thing which we discussed is a fault zone, seismic zone. Narmada Dam itself is in a seismic zone, so we have considered one higher zone for the design, and we have designed the statue for 6.5 meter Richter scale at a depth of 10 meter. So all the important aspect of the design, particularly from safety standpoint of view, we have considered and we have designed accordingly.
Yes, we have second question that is more again connected with your answer, that as it is considered, earthquake forces are considered, to take care of earthquake forces, there are many options available, and tune mass damper solution that is adopted. So any your views about other alternatives and why tune mass damper is adopted?
Yeah, tune mass damper is not adopted for the earthquake force. Tune mass damper is adopted to control the sway, free sway.
Wind force.
Yes, wind force.
Yeah.
Wind force, because you cannot make the structure rigid also, as well as you cannot allow the structure for a free sway. You have to put a control at some level on a free sway. So we have allowed the structure for a free sway of 1 meter at the top. But to control this free sway, we have used tune mass damper. It's nothing to do with the seismic or earthquake.
Correct. Yes, I think in QA box 2 questions are there. Any other participant, if you would like to have any question, you can raise your hand. We will unmute from here. Yeah. In wind tunnel testing of structure, what should be the optimum size of scaled model? Okay. I think sir can give because it is purely structural aspect. Any?
See, what we did is we have prepared 1:1/2 of actual scale.
Okay. Okay.
So if a person is of a 5.5 to 6 feet height, we have generally prepared to the 1/2 of that particular scale.
Okay. Yes. Any other participants' questions? Sir, generally, what design of bridges, buildings has been done for the age of 100 years? In this structure, what is the age of structure assumed in design?
100 years.
100 years, same. Okay.
It is designed for 100 years, but it is maintenance which can give you a more life.
Correct, correct. Due maintenance.
Yes, yes.
Regular
Proper maintenance and regular maintenance will give you a more design life, more than a design life.
And nowadays, we have to consider some environmental load also, actually.
Yes, yes,
for
yes,
the
yes.
sustainability aspect.
Yes, yes.
Because temperature variation is also too high, as well as the level of pollutant that is
Yes.
also increasing. So that will
Yes.
affect the life. Yeah. Yes. Any other questions? Okay, then again, if you will have other questions from the participants, we'll be in touch with you, sir, through mail communication, and we'll try
No
to
issue.
get the,
Anytime, anytime you can send me a query. I'll be very happy to answer your queries.
Yeah. So I think we just one more question has popped up. Let us take it. Sir, with respect to durability aspect, is any other material than bronze was in the consideration for the cladding?
A good question.
Yeah.
We have considered particularly three items, three materials. One is a copper, another is a bronze, and third one is a iron. Initially, it was decided that Sardar Patel was an iron man. Let us go with iron and prepare it. But iron oxidation, everybody knows oxidation part of it. So we have rejected iron, and we had two options available. One is bronze and another is copper.
Correct.
So looking at the metallic part of bronze, we have considered bronze because of a certain metallic aspect of the bronze, because copper is a soft metal compared to the bronze, and the life, design life and durability. If you consider the life of a metal and life of alloy, if you consider alloy's life is a more, whereas bronze is directly prone to the oxidation and giving a green color. So considering all the metallurgy part of it, we have decided to go with bronze rather than copper.
Correct. So one shall not be emotional, that you have to go technically.
Yes.
So
now emotion, when you have used that word, I will definitely like to give one example. Sardar Patel's dream, Sardar Sarovar Dam was Sardar Patel's dream. So keeping that fact in mind, our Honorable Prime Minister, Mr. Modi, has decided, though all the statues around the world is facing the main road, people arriving that particular area can see the face. But here, the people arriving at the statue can see the back. because Sardar Patel is facing the dam, which was his own dream. So emotional connect is also there.
But
Emotional
at least,
connect.
yeah, but at least for safety aspect, one should.
Yeah. We cannot.
Correct.
And being a professional consultant, also we cannot advise them for this kind of thing.
Correct. So thank you very much, sir, on behalf of Marwadi University, Marwadi Education Foundation, and ATAL Academy. We are very much thankful to you for sparing your valuable time, as we were in touch for last week that you are having so many schedules. But however, you have spared some time, and you have made aware about the typicalities of the structure, because the theme of the FDP is that only that when we have new age infrastructure, there is always different kinds of typicalities, and if the participants would know about those difficulties, typicalities which are considered in the design as well as execution aspects, then it will give them more insight. That was the objective of the FDP, and I think that today's all the sessions have served that objective. So I'm deeply thankful to you for sparing your valuable time, and we will remain in your touch for such technical interactions in future also.
Nowadays, actually, students require more of a practical knowledge than only book knowledge. And this kind of practical session will definitely help them in improving or connecting with the practical world.
Yes, definitely, sir, definitely.
Yeah.
Sir, lastly, one more question is
no issue.
What is the difference in structural part in Statue of Unity and Statue of Liberty?
Statue of Liberty inside is a steel framework only.
Okay.
They have made the staircase within it, which is also with a structural steel. Whereas here, looking at the size of statue, because this statue is double than Statue of Liberty. Correct. So in height also. So looking at the height, wind tunnel, we decided that only structural steel framing will not be sufficient enough. We have to go for a composite section, and the important difference is the composite section. We have structural RCC cores and structural steel both inside the Statue of Unity, whereas we have only majority of structural steel only in Statue of Liberty.
Okay, so finally we can close now. So thank you, sir, again, and will remain in your touch. Okay, thank you. And all the participants, thank you for your throughout continuous presence in all the 3 sessions. I hope that today's all the 3 sessions you have found fruitful, and tomorrow morning we will have the session from Dr. C.S. Dev. That also will be on the practical aspects. Majority of all the sessions, they are based on the practical applications. So I'm sure that you will find all the sessions fruitful. So first session tomorrow will start at 9:30 sharp. So I request everyone to join the session by the due time. Thank you. Okay, and thank you, sir. Yeah.
Thank you very much.
Okay.